All right. Okay, it's recording. It's official. Welcome to our first Parent Ed Night. I'm very excited as this will be my very first presentation alone. Last year, Jason and I tag teamed them. So we decided, Emily, Christian, and I of the both upper elementaries decided to present our powers of 2 and 3 that we teach our fourth years in the classroom. And what this lesson does is it helps build the mathematical mind and spatial reasoning by visually showing us the expansion of exponents. That way they can really internalize what is an exponent. 2 to the third power does not mean 2 times 3, but then they visually see that it's 2 times 2 times 2. So we're going to do an activity, and I do this on graph paper with the students, and I have a PowerPoint that will lead us step by step. And if at any point you want to double check or have any questions, just shout out at me. It's it's not a crazy amount of us. I also have my iPad and Apple Pen just to give you a demonstration once I share the PowerPoint. So share that. I'm going to share my screen. All right. Let's get up here. Sorry. Getting used to our new iMac mouse that goes in the opposite direction, but it's kind of cool. Oh, I don't want to share it. I want to present. All right. So our upper elementary night. And we're going to go over the powers of 2 and the powers of 3. So how does the Montessori curriculum help build the mathematical mind? I was lucky to have a trainer, Michael Duffy, who specializes in writing all of these great books about the mathematical mind. And in Montessori, the Montessori arithmetic and geometry curriculum introduced children sensorially, very, very much like they do in lower L. And these sensorial experiences help us understand why instead of just always doing how and doing a rote motion. So the lessons, that we talked about that we teach the students are how to internalize the exponents and see their visual expansion. And I'm going to provide a scale for you of how we will build our exponents on the graph paper. So you have your materials, and this is what we're going to be drawing. So if you were in the classroom, we would put out this layout for you. So if you notice, the first one is 2 to the 0 power. That simply means that is the unit in which we count to get to 2 to the first power. So anything to the 0 power always equals 1. It is 1 unit. So then we introduce 2 to the first power. So notice that we have 2 units. And then we move to the second, 2 to the second power, where we double the width. And then we move to 2 to the third power, where we double the height. Then we move to 2 to the fourth power, where we then again double the depth. Our cycle repeats. And then 2 to the fifth power again, where it doubles the width. And we are going to draw that. So first, we're going to start with our unit. So on your graph paper, go ahead and orient it landscape style, because you'll want room that you can stretch across. And what we're going to do is we're going to use 1 square per face, 1 unit per face, as you notice here. And to make our diagonals, we are going to use the scale of half diagonals, meaning when we double the diagonals as well. So if you could go ahead to the far left of your page, and this is our yellow cube, go ahead and draw 2 to the 0 power, which is our unit. And notice I kind of like to put dots here in the middle to kind of really solidify my half diagonal. When you're finished with that, if you could just give me a thumbs up, I can see everybody right now. Okay. Got it? Great. Okay. Awesome. Okay. So now we start learning a pattern. We start noticing our exponents double in a pattern. So we first double the depth, the width, the height, repeat. So now we're going to do the depth, 2 to the first power, which is 2. Oh, that should just not say 2 times 2. That is a typo, just 2. So based off our 2 to the 0 power, we construct 2 to the first power, doubling the depth. So we started with half diagonal. So if we're doubling the depth, now we'll use a full diagonal. And that stays white, so you don't even have to color that one in. Okay. Awesome. So then in the pattern, now we're going to double the width. Notice that the face of our exponent changes here. So now, oh, what? Okay. Now we'll use, oh no, sorry. There we go. Okay, stay. All right, now we'll use 2 faces and this full diagonal. Our depth does not change. And as you notice, that is green. Great, so just to ask you, this is what I would ask the students as we're drawing. If we're keeping true to our pattern, what would 2 to the 3rd power double in? Would it double in depth, width, or now height? We started with height, then depth, then width. So now we double in height because now we have 2 cubed. And what I love about this material is that the cube is really true to 2 to the 3rd power in that visualization. So now we double the height of the face, still keeping our full diagonal. And that is yellow. Okay, a couple minutes. I have to say, I have gotten much better at drawing cubes since learning this lesson. Kind of a cool trick. All right, so now 2 to the 4. Our depth now doubles from 2 to the 3rd, and our pattern repeats. So now we double the diagonal. Since we're using a full diagonal, we double that. So now we're using 2 full diagonals. Same face. And lucky for us, that one is white, so we don't have to color it in. And anybody want to guess what the next color would be? Anybody? It's green. So we just stay to the pattern. And so now we double from 2 to the 4th, and now our face doubles. Still using 2 full diagonals. So you can see as you're drawing, the sensorial experience of actually expanding that exponent and what it would look like. So now what we would tell the students is, I'm going to stop sharing and I want to see, could you construct 2 to the 6th power? There's no material for that, but it follows the exact same pattern. You're going to double 2 to the 5th pattern. So if we doubled the width for 2 to the 5th, what will we double for 2 to the 6th?
Height.
Height. Yep. So it will be a bigger cube. Exactly. So then our height doubles. And it's yellow because we love our cubes that are yellow here. And if you're done, if you want to hold it up, you don't have to share, but if you want to share, you can. Typically, the children would share in the lesson and we would give them the follow-up. Okay, how far can you go with this? So we had a couple students that 4th years in my class that really took it to the max. I mean, taping graph paper together and everything to create these big, big exponents. It was beautiful. And to me, that was really a natural way they got excited about arithmetic curriculum. But actually, I have to say, my 4th years are all excited about arithmetic anyway. So that's great. Yep. So did everybody end up doubling the face? So yeah.
Is the color pattern white, green, yellow?
Yeah, or yellow, white.
Yellow, white, green.
Yep.
So like every time you come across a cube, that's always yellow, correct?
Exactly. Yes.
And every time it's basically like a rectangle, it's white, and every time it's a half a cube for the lack of better words, it's green.
Yes, exactly.
Just making sure. Okay.
Yep. Thank you. No, that's exactly it. And that's why we just keep staying in that pattern. So it's easy for the children to know how to expand them. So, typically we'd come back next week and it's like, bam, this is awesome. And we're all like excited and counting all the squares to make sure we got it right. So now I wanted to move you through the power of 3 because we also show the power of 3. We use the same scale unit, and I'll share my screen again. That didn't work. There we go. All right. So we're still going to use 1 square unit. So 3 to the 0 power will still be that tiny yellow cube that has a half diagonal and 1 face. So go ahead and start with 3 to the 1st power. 3 to the 0 power, which is 1. And that's our unit. And then because we're tripling now, we're not doubling, and sometimes that would confuse the children a bit. I think I did not. 1, 2, 3. Yep, so now we use 3 half diagonals, which end up a diagonal and a half, because we're doing 3 to the 1st power and not 2 to the 1st power. So I have 1, 2, 3. 3 half diagonals, aka 1 full diagonal and a half diagonal. And that creates 3 to the 1st power. So if we lined up those tiny yellow cubes of 3 to the 0, you would notice that 3 of them fit to make the power of 3. So then you can go ahead and go on. We're going to do 3 to the 2nd power. And we would do this by tripling the face now. But our diagonals do not change, as we've learned. And then when we get to 3 to the third power, our height triples. 2, 3, but our diagonals stay the same. And so then for 3 to the fourth power, using our half diagonal scale, we will now double the depth. So we used 3 half diagonals earlier for 3 to the first. This time we use 6 half diagonals, or yeah, we'll use 6 total, which create 3 full diagonals. And actually, I'm sorry, there is a mistake on here because we would be tripling the diagonals. So it wouldn't be 6, it would be 9 half diagonals. So just kind of extend that back. So that would be 1, 2, 3, 4, 5, 6. Ah, sorry. I don't know why it does that. 7, 8, 9 half diagonals for your length, your depth. And when you go to 3 to the fifth power, we're now expanding the width of the face. So the width triples. 1, 2, 3, and then you'll still use 9 half diagonals for your depth. And I just wanted to give you a visual. In the classroom, this is what the material looks like. And you can actually see how much smaller the power of 2 is compared to our power of 3 on the shelf. And so that's just to really show the big difference that we're tripling now. And after we go through the power of 3 with our students, we invite them to start exponents of their own using the same scale. So for instance, I had a student do, what does the power of 6 look like? And then we did the power of 6, but using the half diagonals. So what do we do with this information? So the next step we do is we teach them how to graph it on a line graph. And this is something I'm going to do with my pen with you and share my graph paper. So sorry, I'm trying to get there. Okay. So now we teach them, exponents are exponential growth. So we show them how to put that on a simple line graph, which introduces them and how to put their data in a line graph. So it's a great way to introduce the X and Y axis. So, we tell them, let me draw on the screen. Sorry. Okay. So we tell them Y axis is always vertical. And our x-axis is always horizontal. So we draw our axis on the graph, and then we'll label it. And what we're simply going to do is show the exponential graph. So down here, we start labeling. We would say, maybe we would say 1. Or, so I would put the values of my exponents, which they've calculated at this point. Sorry. And then here on our y-axis, I would put 2 to the 0, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. And then we just start simply putting our lines. So we know that 2 to the 0 power is 1. So I'd put my dot there. And then they love to get colorful. So then 2 to the first power. Oh, I forgot to. Whoops. Yeah. There we go. So then 2 to the first power is 2, and they would learn how to follow up the y-axis. And then 2 to the second power is 4. 2 to the third power, 8. 2 to the fourth. And 2 to the fifth. And then we just have them draw a line through it. And we teach them that is what an exponential graph looks like and how things expand and double upon each other. So that would be the very last step in the second lesson. We call it the second period when they come back and have practiced. So we would ask them to do that with the power of 3. And then we continue to ask them to do that as they go forth with their other exponents. So that's it. That's what I have for you. Do you have any questions?
Awesome.
Hi, Liz. I'm sorry that you missed it, but I can share our PowerPoint with you if you'd want of the lesson.
No, that's okay.
It's
I'm
good to
good.
see you, though.
Yeah, we're a little late. Sorry.
It's okay. So this is what, both upper elementaries are teaching into our fourth year. So for instance, we get to this about late December, early January in our sequence. So they've been practicing double-digit multiplication, beyond double-digit, and division. And then we go into LCM and GCF work, and then we start our exponent studies, which they all seem to love this because they love drawing and putting numbers with their depictions. So yes, any thoughts or questions or? Great.
I have a question. I'm sorry if
Yeah, go for it.
this isn't in your class, but how long does this take for, because this lesson for me, full disclosure, I had to like really think to follow along. How long does it take for you to get through all of this information? Like
in
to teach them, like how many lessons for the
Okay.
kids?
So for the power of 2, we would do 2 lessons. So we lay it out and we really do the visual first. And then we start drawing, but we do it step by step together. So
Okay.
that ends up being about a 35-minute lesson if they're following along. And they do really well following along on the mat. Then we come back, and after I ask them, okay, can you make, what would 2 to the 6th power look like? What would 2 to the 7th? So forth and so forth. They come back and then we analyze that, make corrections at the mat. And then that's the end. There's no new information. We just correct other than putting it on the graph once we see our numbers. So after putting it on the graph, then we do the exact same process with the power of 3. But Holly, as you know, Montessori is all about reading your group and your child. So if it's going to take more than 2 lessons, it does. Sometimes it may just take 1 lesson depending on the group. So for instance, my group now that I did this with, they went through it pretty quickly. Like they were able to understand it, they got it. And even the ones that had a little bit of trouble when we came back to the second lesson, that redirection and just helping them out really made it clear. I will say it was hard for me at first when I learned it too. And I had to also really, really think about it because of the diagonals. Like my brain, I have gotten so much better at my own spatial reasoning through teaching this curriculum because that was something that was difficult for me as well. So that's ideally spending about that time. And then, you know, after we do that, we spend on time like just expansions in general and really practicing, okay, UC2 to the 4th power. What does that mean? And we want them to say, that means 2 times 2 times 2 times 2. And that is our goal, to just keep being super repetitive. That way, that careless mistake of, oh, that just means 2 times 4 goes away. So that's the goal, you know.
Thank you. I was just
Yeah.
curious.
Yeah, you're welcome. And of course, I went through this quickly with you all. I would never move this quickly with the children, but I wanted you to see the full layout of what we do. And it's kind of cool. Like I wish I would have asked my students this now. I want to ask them, if you made a material, what would the power of 4 look like material wise? So maybe that's something we incorporate next year. But I would have to know how to do it too first. I'm not good at making the 3D cubes. Anyway. So what I do love about the Montessori math, that something that's new to me, and Emily, Christian, and I both work with a consultant from our school who's just wonderful and really helps support us in showing us different lessons. But I never realized just how much at this level in upper elementary, you really can do these visual sensorial math lessons on graph paper. So for instance, when we all had to go remote and none of us knew what to do last year, like just even being able to adapt it that way. And so now it's a huge part of our curriculum because not every time a student can get their hands on the material if somebody else is using it. So we use graph paper representations a lot, and Zach can tell us because he knows. So, yeah. And I love seeing their face when I pull out the power of 3 because it really is just so much bigger than the power of 2. There's no true reason for why they scaled it that way. We've asked all kinds of trainers. We just kind of make our assumptions that it's to show, you know, we're tripling, but I mean, their eyes get just so big and the gasp of the room. It's really fun. Yeah. Well, if you do have any more questions or anything, feel free to contact us. We love talking about curriculum. You know, it's our life in a good way. So anything. And I really appreciate you coming to our meeting. This is actually I told you, my very first parent ed night solo. So I'm glad I feel like I had a decent crowd here, a really nice crowd. So thank you.
Thank you.
Yeah. All right. Well, I hope you have a lovely, lovely evening. And yeah, happy almost spring.
Great, thank you.
Thank you.
Thanks.
Thank you.